Okay, this is still section 7.3. This is for the second day, talking about dividing polynomials. So the first couple of videos were for long division, dividing two polynomials using the idea of long division. A different way to divide polynomials is called synthetic division. Now, there are some restrictions with this. You can only use synthetic division when you are dividing by a polynomial in that format. It's got to be a linear function. It's got to be a 1x minus a number r. All right? And a different thing, with the long division, you didn't need to have placeholders. You know, if you skipped over an x squared, it was no big deal. But with synthetic division, you must have placeholders. If there is no x squared term, you've got to put a 0 in its place. So, synthetic division, it takes a little bit of a different format. But we have this polynomial that's x cubed. We're dividing it by x minus 4. What we're going to do is put the 0 of that divider, so 4, into this little corner box. And then we're just going to put the coefficients of what we're dividing into. 1. And I'm going to leave a little bit of space in between these numbers. So 1, negative 2 is the next coefficient. Negative 3 is the next. Negative 20. Okay, we got an x cubed term, we got an x squared term, we got an x to the first term, we got a constant. We're not skipping anything. Leave a little bit of space, draw a line going across. All right, how this synthetic division process works. That first coefficient of 1, bring it down underneath that line. Then you're going to multiply 4 times 1 and put it underneath the next coefficient. So 4 times 1 is 4. Add these two. Negative 2 plus 4 is a positive 2. Now we're just going to repeat this process. 4 times 2 is 8. Add. Negative 3 plus 8 is a 5. Now we got 4 times 5. That's 20. That goes underneath the next coefficient. When we add these up, we get 0. So for this synthetic division process, it is essentially done. We just got to, add a couple of things to this to finish it up, to make it look better. This last number in the synthetic division process, it is always the remainder. Okay, that's the last number that you got there. That's the remainder. So with a remainder of 0, that means what we divided by was a factor. So we took an x cubed function and divided it by an x function. X cubed divided by x is x squared. This is what we're going to do with these numbers. This 1, 2, and 5, these are coefficients, okay? But again, x cubed divided by x is an x squared. So what we have is a 1x squared. It's a positive 2, so plus 2x. It's a positive 5, so plus 5. So the answer to this division is x squared plus 2x plus 5. And the remainder is 0. So what we could say is this polynomial that we divided by, x cubed, or divided into, I should say, minus 2x squared, minus 3x, minus 20. This is x minus 4 times x squared plus 2x plus 5. Okay? And again, because the remainder is 0, we know those things are factors. But this is the synthetic division process. Let's do another example. Let me extend the page here. So let's do, I'm just making this up, x to the fourth plus 3x cubed minus 7x plus 5. And we'll divide it by x plus 4. Okay? So, this division, synthetic division process, what we are dividing by, it's got to be the form of x minus r. We have x plus 4. So we're going to put a negative 4 into this little corner, and we use our coefficients. Okay, we got 1x to the fourth. We got 3x cubes. We have 0 x squareds. We have a negative 7x, and we got a constant of 5. Leave a little space, draw your line, bring down the first coefficient, and then you multiply. Negative 4 times 1 is negative 4. Add those numbers up. That's a negative 1. Negative 4 times negative 1 is a positive 4. Add those. Negative 4 times positive 4 is a negative 16. Add those, that's a negative 23. Negative 4 times negative 23 is going to be a positive 92. Add those up, 97. So this last number is our remainder. All right, we took an x to the fourth and divided it by x. We get an x cubed function. So these numbers, other numbers here at the end, these are our coefficients. So we got 1x cubed minus 1x squared plus 4x minus 23. That's the quotient, and if we add on the remainder divided by what we divided by, this is the answer to that division problem. Okay? Synthetic division, it's a little bit quicker, and you know, it's just kind of nicer if it works. You have to be dividing by that linear function of that form x minus r. But this is that synthetic division process. This is how it works. The next idea with this is going towards that idea of the remainder. Actually, I just got a little bit ahead of myself. Let me finish that thought. With the synthetic division process, that last number, it is also, it's the remainder, but it's also the value of the function. When you plug in that value of a into the function, when you're dividing by x minus a, the remainder is that value. So, what we can do, to find f of 6, we're just going to use the synthetic division. We're going to do 6 and our coefficients, 3, negative 4, 9, 5. So bring down the 3. 6 times 3 is 18. Add those up. That's a 14. 6 times 14 is 60, 84. Oh boy. Add those up. We're looking at a 93. 6 times 93. 545, 58. I hope I'm right with that. I think so. But I think it is. And then add those up. We're looking at 563. So the value of f of 6 is 563. So we can use this synthetic division process to get that remainder, which is the same thing as evaluating the function in the next value. You know, why don't we just plug in 6 for x? And you can. You'll still get 563, but it gets rid of all your exponents and following order of operations. You just got to do some adding and multiplying. Okay, so it's one way we can use this. One other way we can use this synthetic division. Now, let me back up a second. All right. Another application of synthetic division is this example here. Whoops, messed up the format. It says, given that 2 is a 0 of f of x. So like we talked about right at the end of the day 1 notes, if a number is a 0, it means it's going to be the factor x minus that 0 is going to be a factor. So we can use this fact to help factor up our function. So what we're going to do is, 2 is a 0. So I'm going to plug it into that little corner box. We got 1x cubed. We got a negative 3x squared. We have 0 x's, and we got a constant of 4. All right. Because 2 is a 0, I know I should be getting a remainder of 0. So, synthetic division process. Bring down the first coefficient. Multiply 2 times 1. That goes underneath the next coefficient. Add those up. Negative 3 plus 2 is a negative 1. And repeat. 2 times a negative 1 is a negative 2. Add those up. Multiply. 2 times negative 2 is a negative 4. And there's that 0, just like it's supposed to be. So we took an x cubed function and divided it by this x function. That means we got an x squared, 1x squared, minus 1x minus 2. Because the remainder is 0, this is a factor, and so was x minus 2. Now, I think this factor is a little bit more. We got x and x, minus 2 and a plus 1. X minus 2 happens to be a factor twice, so we could write this answer a little bit better. X minus 2 quantity squared times x plus 1. All right, we just used the synthetic division process to help factor. Given 1, 0, if 2 is a 0, x minus 2 is going to be a factor. And so we use the synthetic division process to give us the other factor. And then we factored that a little bit more, and now we've got the whole thing that's factored. So that's it for synthetic division. Bye.